Everybody, my name is Francis Walsh, and this is a presentation that I prepared on the 4 lean principles as a part of the Engineering Management 530 course in fall 2024. So the first thing that we're going to talk about is what is lean and what exactly is it and why we should use it. Then I'm going to talk a little bit about the 4 lean principles, and those 4 principles are pull, one-piece flow, tack, and zero defects. And then after that, I'm going to talk about how engineering managers can integrate these principles into continuous improvement. So what exactly is lean? Lean is a manufacturing philosophy that centers around delivering value to the customer. So in order to do that, we minimize waste and improve the efficiency of processes and tasks. It was developed in Japan in the 1940s and 1950s by this guy on the right, Tachi Ono, and he worked at Toyota and worked to improve the Toyota manufacturing lines. It was inspired by Henry Ford's assembly lines in America, and the Japanese took those learnings over to the post-World War II rebuilding of Japan. Today, it is widely used in numerous industries. So the 4 lean principles, what are they and how can we use them? The first principle is pull. And the idea is that we want to drive production using customer demand instead of using forecasts. So what that means is that the customer orders and then the factory makes that the order. Instead of trying to guess how many units we're going to need, stockpiling them somewhere, and then delivering them to the customer as they order them. And sort of the benefits of that are that it reduces inventory costs since you're not storing as many parts, which is wasteful. We're reducing the number of unsold products since the forecasts aren't always accurate. We're reducing unused resources, so we're not using electricity, water, whatever you need for manufacturing to build parts that you don't need. And it increases the responsiveness to the market since you only need to build as many units as you need to deliver. So shown on the right here is just showing how in the very top, this is the batch. So you see each station makes whatever in their process. And then before and after each station, there's this kind of like inventory state. Whereas in a pushed production or one that has pull, we are moving these materials directly down the line and there's no need to store them anywhere. Kind of like an example of what this may look like in someone's everyday life. So in a push example or one where we do lots of batch food, so when you go to a restaurant, you go to a buffet, the buffet forecasts how much food we need for lunch hour, dinner hour, and they prepare the food, and often a lot of that food gets wasted. There's a lot of wasted time in preparing the food, whereas if you look at a restaurant such as Five Guys where food is made to order, that's kind of more like a pull system. There's less waste. There's less amounts of food thrown out at the end of dinner service or lunch service. So that's kind of an example of push versus pull and batched versus pull lean principles. Now, the second lean principle is one-piece flow. And this is kind of similar in the fact that items are produced one at a time and minimize batching. So again, it's that exact same idea of we want to get rid of the batches before and after each station. So each step completes a single item before passing to the next step. So you can look here. So this step in a batched system, we're moving one item into inventory and then that gets moved again to another inventory, it gets moved to the next station, whereas we're just passing it all the way down the line here with the one-piece flow. So the benefits of this is that it reduces work in progress inventory. So again, that's reducing your warehousing costs, the amount of waste that's used for moving those parts around. It also greatly improves product quality by identifying defects immediately. So if you can imagine if somebody at station 1 isn't doing their job right, they've already made 20 parts, 20 defective parts, and then they're going to station 2. Station 2 doesn't realize that until this inventory right here, incoming inventory for station 2 is being used or used up or gets to that part. So we get to identify defects immediately. And then the other thing is that it enhances our flexibility because we don't need to put as much storage areas in our factory floors, our warehouses, such as that. So, and my example here for how like one piece flow is implemented in like industry or some like in your everyday life. So you can imagine in a conveyor belt sushi restaurant, the chefs again forecast how much they need for a lunch special or whatever, and they put it out on the conveyor belt. And let's say there's some bad sushi, some bad fish that's making people sick. They won't know until a customer eats it and complains, but there's already a ton of it on the conveyor belt. Whereas, say, in an omakase sushi restaurant style, the chef prepares every single piece and is inspecting it, making sure that it's great, making sure it's perfect before it goes out on the table for the customer. And so you're identifying like those defects early. It's more responsive. Say if someone wants another piece, they can ask for it. Whereas, you may run out of sushi types on the conveyor belt sushi. So the third lean principle is tact. And tact time is the pace of production which is needed to meet customer demand. So this is kind of this is not exactly batched or forecasting. It's a little more nuanced than that. And basically the idea is that you want to reduce the amount of overall time spent at a station to make or complete the process so that you're moving things efficiently through the factory. So basically you reduce the amount of time it takes to produce one of these products. So kind of the benefit of that is that it reduces idle time. It enhances predictability and flow since you're using a minimum amount of time possible. And it also helps to identify bottlenecks and adjust resources accordingly. Because if you can imagine, if one station is taking a long time, you really need to work to reduce that, since that could be a bottleneck in a series operation. And kind of my example here is airport security. So airport security, going through airport security always takes the same amount of time. They have a very specific tact time. But when more people come, they open up more lanes because they know that the tact time is the same. So they let more people through in airport security in one time. So finally, the fourth and last lean principle is the concept of zero defects. So you want to focus on getting your products out with no errors. It's kind of this idea of doing it right the first time. So you prevent defects versus correcting later. And the way how this is implemented in industry is by using air-proofing techniques and trying to continuously improve processes and assembly and stuff. So the benefits are that it reduces wasted material, reduces rework costs, enhances customer satisfaction and trust, and builds a culture of accountability amongst the workers, since they all need to work with each other. And kind of my example here for how this is used in everyday life is that this is an air-proofing technique. And this air-proofing technique is using meat thermometers for cooking food. Because imagine you have one turkey. You need to get it right. You paid a lot of money for this turkey at Whole Foods. You really need to get it right. You don't want to waste any money. So in order to avoid any defects and reduce value to the customer, the people that you're feeding, you want to use a meat thermometer to absolutely make sure that you have no defects, and you don't need to go out and buy another turkey, find a place that's open on Thanksgiving Day. So that's kind of the idea behind one piece flow or zero defects. Lastly, talking about the 4 lean principles and continuous improvement. You can't just implement these principles all at once. They're kind of hard. They're big. They're audacious goals that you need to meet. So you always need to be, as an engineering manager, you always need to be trying to work these principles into your everyday life, and achieving this continuous improvement, this idea of Kaizen and the Lean principles, also dreamt up by Ono in Japan. So like, and when it comes to like trying to continuously improve and implement these, it's engineering managers that really are the key to empowering teams to improve their processes, because they are the ones that need to go in, talk with people, make sure that they know what's up, and that they're doing good stuff. And then finally, just talking like with the continuous improvement, if you're always making very small improvements over a long amount of time, they all start to compound. And of course, my favorite example of this is 1% every day for 365 days compounds, 37 times more than if you do nothing. So, we always want to be using these Lean principles every single day. So thank you very much. I hope you enjoyed my presentation. My name is Francis Walsh.